Welcome to TechPacks, your partner in advanced research and development. In this video, we will be presenting the details about one of the most demanding research projects titled Decision-Operated BAD Approach for Stable Network Clustering in Wireless Sensor Network. This research project can be extended further to publish a research paper in a reputed journal or used for your PhD or MTech thesis. So, if you are a researcher, PhD, or MTech research scholar working on a similar research project and need expert guidance to handle the complexities of research in this field, you're in the right place. Watch this video till the end to gain valuable insights into the project's objectives, methodology, and results. We'll also provide a demo of the code in action, showcasing its key features and functionalities. So, let's begin. Our professional researcher will now take the lead and guide you through the details. Here we go.
Hello friends, welcome to TechPacks Research and Innovation Services. Today I'm here to present you one of the application area that we have designed for the sensor networks. It can be implemented for the wireless sensor areas or for the IoT based applications where sensors are playing their crucial roles. And in order to save the energy, we have proposed this methodology. So before moving to video, let's talk about that what we will cover into this video. In this video, initially we will discuss about in which application areas this can be implemented and where it is successful and useful. Then we will talk about that what code we have designed and how to execute it, which file is to be executed, along with the software requirements and the library requirements for it. Next to that, we will discuss about what current systems are there, what are the general problems they are facing, and what novelty and effective task we have added to the proposed methodology. Finally, we will have a review to the experimental outcomes and the findings that come out after the simulation. Let's talk about the application areas. So sensor based networks are quite interesting domain and now currently are useful in the internet of things based applications, where in the smart homes, smart transportation, smart cities, healthcare applications, smart agriculture based applications, there it can be very much successful. The main fundamental behind the sensor network is like at the remote locations or the location where continued monitoring or tracking is required, the small sensors are used in order to track the factors. And the challenge among that is like these sensors are operated on the basis of the batteries. These batteries are very smaller in size and need to be more reliable and long lasting. So that is basically the main challenge of the wireless sensor based communication networks. So all these areas are where these sensor network applications can be implemented. Specifically, a secure communication from the sensor to the base station is required so that remotely it can be accessed. Even the sensor based monitoring can be accessed. So in order to save their energy, certain protocols have been proposed. What we have proposed we will discuss in the further phases of the video. Now let's talk about that, what is the code and how to execute it. We will provide you the folder here, the folder name code, under which the whole code files are there. All these files are implemented in the MATLAB, so we must have the MATLAB software with us. So the MATLAB version that I am using is of MATLAB 2019. You can use MATLAB 2015 or the higher version. Just make sure it should be a full version, uh, because the trial version is not having all the libraries with it. So in order to run the code, you just need to go to the folder here and you just need to copy the path of the folder. Then go to the MATLAB and then select here and paste it. When you paste, press enter. When you will press enter, you can see all the files those were there in that folder are here. Now there are three main files that you need to run. One is the base paper code, the reference article that we have considered for the research. Initially we have implemented that. Then the proposed method, that whatever the technique and the technology we have proposed, it is there. Then we did the comparison among all the factors of the proposed and the existing method, right? So in order to run the code, you just need to select the file and then you need to click on the run button. When you will click on the run button, it will start executing the process and everything will be executed. The whole code is written in the MATLAB. If you will click on the run button, you can see it start processing the number of iterations and number of communication rounds. So for after the defined rounds, the results will be represented. So let's see what exactly the current system was and what we have implemented. So these are the base paper results that I will give the overview later on. Initially, let's talk about the problem. So we were using this base paper as a reference of our research, in which they have implemented the energy efficient hierarchy clustering and routing based on the FCM. I'm giving you the brief that what exactly they have done. They have splitted the network with using the FCM, fuzzy C mean, which is a clustering approach. Then they have they were doing the communication through the grid heads and the cluster heads. So they basically split the network into the grids and then chosen the grid heads. Then in each grid there are number of clusters, out of which they were using the cluster heads. So for that they have given the mathematical models for that. So you can, I just highlighted the sections. This was for in this was the algorithm where you can see fuzzy c-mean algorithm is there. So grid head selection is there, cluster head selection is there, then the data communication was there. Grid head selection is done by calculating the methods, like in order to get the centroid. So initially by using the FCM, they are selecting the centroids for the grid formation, and then on that behalf they were just creating the grids. Then they were selecting the grid heads by using these formulas, where they are calculating the FGH, which is also known as fitness for a node to be a cluster head. So on this behalf, the nodes in the individual grids are elected as a grid head. Once the grid head has been selected, then the cluster head is to be selected, through which they have done the mathematical calculations and did the selection of the cluster head by using this scenario. So you can see here basically they were working on the residual energy and the distance among the node to the cluster centers, right? So these are the two factors that they have considered, and this algorithm is given name as EHCR FCM. So FCM for the cluster formation basically. So what problem we have identified? We have identified that the on fuzzy C-mean for cluster formation is not enough, and the factors that they were using were only the energy and the distance among the node. So this should be automated, this should be in the dynamic manner. So the selection of the grid head is smaller. It means they just need to divide the grid whole cluster into grid. So fuzzy c-mean for the grid head selection and grid formation is good, but for the cluster head selection there should be some advanced approach which can assist in any of the scenario at the faster rate. So we have proposed the scenario in which initially we were forming the grids by using the fuzzy, because they have proven it as a effective approach. Then grid head selection has been done at the similar scenario as they were used into this, but for the cluster head selection we have applied a new algorithm named BOA. BOA is basically BAT optimization algorithm. So here you can see BAT optimization algorithm. So this is termed as BOA, or some people used to say it as BA, right? So in that we have chosen different parameters that includes let me show you that what we will done. That includes the residual energy. Here you can see the residual energy, number of nodes in the cluster, and the Euclidean distance from the centroid. Second main contribution what we have done, instead of using only BOA BAT optimization, we have applied the fuzzy model in order to evaluate the node, that which node can be clustered, because when there are only one or two parameters then it is easy to check only maximum and minimum value, but when the parameters are increasing we need a decision model. So we have used the fuzzy decision model, fuzzy logics. One is fuzzy c-mean clustering, which is used for cluster formation. One is fuzzy logics, that is basically a controller to take the decision on the rules given by the user. So we have generated the fuzzy system. So these are the improvements that we had made in the current system. So let's see how to execute, what is to be done and how it is done in the video. So you can see in order to run the code, we have initially defined the configuration that was given in the base paper. Then for the for FCM has been implemented on the nodes in order to get the centers for the grids. On that we have formed the grids by checking that which node is nearer to which center. Later on the grids has been drawn, Once the grids had been drawn, we have chosen the formation of the clusters, where 4% of the grid nodes has been used as a uh, plus clusters. So it means there will be 4 clusters in each grid. Then on the fuzzy C means we have calculated the centers for the clusters. Then we have used the mathematical equations given in the base paper. You can see this is for grid 1 and grid 2. uh, Grid clusters has been generated, the information related to them has been generated, that includes the energy and the distance. And then on these basis, the equations those were given in the base paper, d mean is calculated. Paper you can see they were initially calculating the d mean, d max. So on that behalf we were calculating the parameters, and then after that main protocol start, where FGH is calculated, and the node with the maximum FGH is calculated as a grid head. Similarly for the grid 2, then cluster had been selected by the same scenario that was given in the base paper. So this is the implementation of the base paper. After simulation we got the result like this. These were the nodes, this was the grid formation. One color represent one grid, second color represent second grid, and then the results has been shown that what exactly EHCR FCM is achieving after implementation. And finally, first node add, half node add, and last node add has been implemented. This is the base paper implementation. Now let's talk about the proposed one. So in the proposed section, what we have done, the initial scenario of the grid formation is quite similar with the FCM based count of the grids. Then the grids has been drawn, and then the cluster are formation with the same scenario by finding the points from the FCM. But the grid heads are being selected by a new scenario where grid heads has been selected at the same scenario by calculating the d mean and d max, which was earlier in the base paper. But the cluster head selection has been done in a different scenario where we have calculated the parameters. Those parameters are basically residual energy, number of nodes in the cluster, and the Euclidean distance. So these factors has been calculated and passed to the BOA optimization algorithm, which we have defined here. This is the whole algorithm for the BOA in which the fitness is being evaluated. The fitness function that we have used for the optimization algorithm is basically here the cost function. So you can go to the cost function where we have called that fuzzy system, which we have generated in a separate file that I'm going to show. And the factors that we took will be passed to this fuzzy by using the eval function, which is uh, getting the input in terms of the energy, node count, and the distance among the nodes. And on that behalf it is providing a weightage. So the node with the highest weightage will be selected as the cluster head. So let's see the fuzzy system. The fuzzy system is basically having the three factors within a threshold range, that how much range for the residual energy, how much range for the nodes in the cluster, how much range for the distance, because these values depend upon the initial parameters that we have decided in the initial factors. Here you can see the area, nodes, initial energy. So by using this we have generated a system, and then we have defined few rules. And when I'm running this, you can see the fuzzy system will be generated and will be saved as a uh, selection ch.fizz file. So here you can see this fizz file is a fuzzy file which is generated from this system. So here you can see there are three membership function and all. 27 rules are given to get the weightage from 0 to 1. So this fuzzy file has been used with the BOA in order to evaluate and get the weightage for node to be the cluster head. From this weightage, we were choosing the cluster head. Here you can see uh, once the BO is applied, the node with the best weightage is selected as a cluster head. Then the communication is being performed, where firstly communication is done between nodes to cluster head, then cluster heads to grid heads, and then to sync. So whole communication models has been implemented into this, and the results has been considered, and finally an analysis and comparison has been made. So when I'm running this, you can see it will take some time to simulate the results. Might just wait a minute. There's one additional factor by mistake. I'm running it again. So you can see this is the network. In our case, the network is like this. Then it will show that what exactly the grid is. It will take some time to get simulated because in this scenario BO is having the different iterations. So in every iteration it will take certain rounds, so might be speed will be slow, but the system is considered to be faster. So to compare the results, we have saved the results with us in the proposed result.mat file. You can keep running this folder and this will give you the results and we'll compare, but we have currently saved it to the new scenario. So comparison code will load the results and will compare. You can see when I'm running this, it will show us the graphs in the different figures. Here you can see these were the three base papers to which the base paper was comparing. EHCR is the base paper's outcome, and finally POA fuzzy is the proposed methodology. So let's see the results. So results are basically having the different figures. One is for the lifetime evaluation, so you can see the proposed methodologies. First node dead is for the later on period. Even the half nodes are getting dead very later, and last node is also very later. So it shows that it is better than the EHCR base papers and the previous models those were proposed by the different researchers in their research. This is the alive node per round, in which with respect to the number of communication rounds, the alive node graph is shown. So you can see the pink curve is of proposed method, which is staying longer for around 2000 rounds, and then it get degraded to the zero. All the nodes get dead as per the communication scenarios we have given, which is much better than the EHCR, normal FCM, HHCA, and Leech. The results of Leech, HHCA, and FCM has been taken from the base paper because they have already given us the outcomes. So we have taken the results from here but implemented EHCR by our own in order to demonstrate that what exactly we have achieved. So further modifications are still possible into it. For those details you can contact us directly. These are the methodologies, those can be implemented in the real world IoT scenarios, sensor based networks, in the certain different domains like biomedical, healthcare, smart homes, smart agriculture, and many others. So industrial research or the PhD related research, you can contact us directly and can get the improvements into it. Thanks for watching the video. Thank you.
Thank you for watching this video. We hope you found it informative and engaging. For more information about this research project and to get our consultancy services, click the link in the description below. At TechPacks, we offer comprehensive support for researchers, PhD, and MTech students in the fields of engineering and ICT. Our services include selection of research topic, helping you choose the right topic tailored to your interests and the latest trends. Synopsis preparation, crafting a clear and concise synopsis with well-defined objectives. Coding assistance, providing expert help with writing and optimizing code in various tools and platforms. Research paper writing, assisting in drafting and editing research papers to meet the highest academic standards. Dissertation writing, offering complete support for your dissertation, ensuring consistency and quality. Plagiarism check and removal, ensuring your work is original and free from plagiarism with advanced detection tools. We also offer customization services to meet your specific project needs. Whether you require a modification of an existing project or a completely new application, our team of experts is here to help. Don't forget to like, share, and subscribe to our channel for more updates on cutting-edge research projects and expert advice. Thank you for choosing TechPacks. We look forward to collaborating with you on your research journey.